Okay, so this is a repeat class from earlier this week that we had to deal with. We were dealing with security, fire, and surveillance, and this class is just going to talk about the way the security alarms or security systems are solved and approached. Okay, so can I do this? There we go. Now, there are three YouTube videos that I posted here. Once you download this this presentation, you can click on those and see some of the equipment that is involved. I think these are like minute and a half short snippets introducing a certain type of security equipment just to kind of get you in the mood and just so you know what song is being sung when it comes to this type of equipment. All right, so I'm not going to play those here because well, you can watch it at home, and I'm going to continue with something like this here. All right, now this is main board, or well, if this were a computer, you could call it a motherboard. But when it comes to this type of equipment, well, the terminology is quite often you're going to say a main board. So here's a main board for something that is a basic security alarm. This would be enclosed in a box. I think it's like 10 by 10 box or something like that, which also includes a battery and ways to bring in the wiring. And there's going to be a hinge to close the thing and maybe put some label in front of it, right? So everything. So, but if there's those mounting holes right here, and here. All right. Okay, cool. So we're going to analyze this thing a little bit. All right, so on top of that here, whatever, right here, the first thing that pops at us, you can see that DL2032 battery. It's just basically a watch battery. This one here is just like computer BIOS. It serves similar purpose, just to keep some of the system's memory. Part of it is maybe a time and date and things like that. So so that usually this thing is being replaced every so many years. All right. So here's that battery. Now, moving on to the left, we have these two items. Here's a fuse and here is a connector. I'm going to zoom in here. Now, I have further slides that are zoomed version of this, but I'm just going to keep zooming on this thing here. And once we are done through this board, I'm going to just flip through those slides to get them out of the way. So look at this here. Here's a connector. And over here, if you look carefully, you can see red and black markings. See, this one says red here, and this one says black. This is to this connector. The purpose of this connector is to provide connection for a backup battery. Right? It's well, about 7 amp hours is pretty common ones. Common battery it's an acid lead acid battery, and it's enclosed and sealed because it's going to be enclosed in a box with a whole bunch of electronic equipment, and you don't want this thing to release any kind of gases. And those batteries you can buy anywhere from $20 to maybe $60, depending on who sells them and what brand and whatnot. And those batteries are being replaced every maybe 3, sometimes 4 years I've seen. But about 3 to 4 years, it's a good thing to. Well, the other thing is that on the keypad, the alarm is going to let you know if the battery is kind of done. It's going to come up with a trouble light, and if you punch in the code to find out what the trouble is, then you're going to find out, okay, it says battery failure, which means the battery is kind of towards the end of its life. So the purpose of this thing here is to charge the battery, the backup battery, and if the power goes down, the whole circuitry switches to getting the power from the backup battery. So if the power goes down for maybe an hour or hour and a half or 2 hours, you might get some life. The system can continue getting the power from the backup battery. Now, I get questions from clients quite often if when I'm installing those. How long do we have if the power goes down for this battery, right? Well, there's no simple answer to this question because it all depends. How many active devices do you have that the battery needs to power? Some of the households or small businesses or larger businesses, they have more active devices such as motion sensor or glass break detector or some other maybe expansion boards. Then those all consume power. So, of course, if you have more devices that require to be powered to operate, then it's going to use the battery quicker. And if you don't have any active devices, which is impossible because keypad is an active device. Active device is a device that needs to be powered to operate, as opposed to just a simple switch that opens and closes based on the magnet being brought to it. Then that thing doesn't need to be powered, so it's a passive device. Excuse me. Okay, so here is the backup battery. Now, moving on to we're going to ignore these two connectors. We have that one here that's just serial, and then there's a memory key. That memory key, I'm pretty sure they could almost get rid of by now, because those systems are being programmed with laptop for the most part, and you can save all the programming onto your laptop. And if something goes wrong with the board that you have to replace the whole board, like for example, lightning hit, like can fry the circuitry, you just get the same board and you upload the programming from your laptop. What used to be popular years ago is that most of the programming could be done, or well, you can still do that, but it's just a treacherous process. But it's still doable to program the whole thing from the keypad. And then if you want to keep the programming, you would get a memory stick that is made by the company who does this thing. This produces this equipment, and you just pop this thing in and give a command for the programming to be pushed onto that memory stick, and you would keep it somewhere for just in case something goes wrong, so you don't have to reprogram the whole system from scratch. Right, so that's the thing here, and for the most part, it's not being used. Just like the automatic dialer and the eBus thing. So I'm not even going to mention those. All right, here is one that you're probably going to use a lot. Here is the serial port. Now, for the most part, there are two main reasons for this thing to be used, and one of them is to connect with your laptop if you want to do a direct cable connection onto this board. So you would get your laptop, and for your laptop, you would need something that is called a serial port interface, because the laptops used to have serial ports. Now, very rarely you can see a serial port incorporated into a motherboard of a laptop, but you have something that's called it's like a little box, about this size. That is called a serial interface. So on one end, it has a USB cable, so you can plug it into USB port of your laptop, and on the other side, it has a 9-pin serial port interface, and then you get a cable, specially made cable, proprietary cable for this. Plug it in, and you can connect to this whole board with your laptop. Also, what you can also use this for is connecting something that's called the IP module, Internet Protocol module. And the IP module is, well, on one end, it has a little tiny cable that plugs into it, and then the other end of the cable plugs into the serial port. And on the other side, it's almost like an ATA adapter for the phone systems, but this one here is, well, connecting the alarm system. So on one end, it has the cable that connects to the serial port of the alarm system, and on the other side, it just has an Ethernet jack, just like a computer jack, so you can connect this whole thing to the network. And then you can still program this system with your laptop, but you don't have to connect it to the serial port. You just plug the laptop to the network, the LAN, local area network, that this thing is on, and you just have to follow the proper instructions of how to access this particular equipment, right? Also, with the IP module, if you need to, client has a trouble, forgot to how to do something, or maybe something went wrong, maybe doesn't remember how to reprogram the date or time and date or something, or maybe there's a well, because the clients, their job is to run their business, and not necessarily they're going to remember every little detail about the alarm system that you installed. So they might call you and say, "Look, one of the people that worked for us is not with us anymore. They just left for another job, and we just need to make sure that the code that that person has is not active anymore." So you can remotely access. You can program this thing. You can access this thing from your home through the internet that you can connect to the IP module through the network, which is connected to that. So the serial port is quite useful thing right here on the thing. All right, on the alarm system. Now we're going to look at these terminal strips. This is a long row of a strip here. All right, going from the left. Here are the two screw terminals, compression screw terminals. That's called AC. This is where the whole system gets its power from. Are you plugging it into the 120 volts AC? No. What you plug in here is the output of a transformer. And it is designed in a way that it can be connected to something, it could be connected to something that is commonly called as a doorbell transformer. So on one end, it plugs into 120 volt AC. And on the other end of that transformer, there's about 16 to 18 volts AC, so that this system is set up so we can use that. Now, those transformers can be also, they come in basic two versions. One is a plug-in transformer, which is, well, it's a box with prongs that you can plug into the receptacle, just a regular 120 volt receptacle that most of the households have in the walls. And on the other side, there are screw terminals to which you can connect a wire, and usually it would be a stranded 18 gauge, sometimes 16 gauge pair or conductor. Commonly, sometimes it's mistakenly labeled as a speaker wire, right? But it's about 18.2, which is 18 gauge, or 16 gauges as well is okay too. And you just plug in here, and that's it. The other version, other than the plug-in transformer, is something that's called a wire-in transformer, and it provides the same output, but it has a like a lock terminal. You can knock out terminal that you can wire this thing. You can mount it right onto the electrical panel, and it has a lock nut on the other side, and you can screw that on, and it just sits on the side of the electrical panel. Now, for that one, you can wire straight into the electrical panel, and even you can, if you can, which pretty much is a good idea for the alarm system, you can wire that end of the transformer straight into a dedicated circuit breaker, right? And then on the other side, again, you have screw terminals that you can wire that into those AC terminals. Okay, moving to the right. Here's the thing that's Bell. Okay, this is the noisemaker. This is the noisemaker terminal. When you watch a bunch of movies that people are breaking into the banks or so whatnot, you can hear that the burglar are wearing that weird hat or something, just going there and trying to open something, and bang, 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 there's that alarm bell going on, making noise, and okay, so let's run away. So that's where the bell comes from, right? Because from the old early versions of the alarm systems and the terminology stack here, right? Now, with this one here, what happens if there is an alarm condition where the system is programmed to make noise, then because you can also have a silent alarm, right? But if it's programmed to make noise, it's an audible alarm, then you're going to see 12 volts DC appear on these terminals. And those bells or sirens right now called, they look like, some of them look like a 8 by 8 inch square box that can be mounted on the wall. And some of them look like paging horn, but they're not a paging horn. They have the same shape, but you can't just connect a microphone to it and speak to it. It basically has a couple of terminals and it's looking for 12 volt DC voltage, and if it sees that 12 volt DC voltage, it's just going to go nuts in a way that it is designed for the human brain and human ears to be very uncomfortable with. And as far as those bells or sirens, they come in 15 watt and a 30 watt version. The 15 watt is pretty darn annoying and loud. Don't be fooled by the 15 wattage there. It gets pretty annoying and loud. And then there's those 30 watt versions. You just don't want to be in the room because it just produces a certain type of noise that we humans, I just don't want to be there. All right, so that's the whole purpose of it, right? Okay, so that's the bell terminals. Then we have 1, 2, 3, and 4 program buttons. In this case, in the case of this particular model that we're looking at, those program outputs can be programmed to either, and I'm not sure because different models, different versions, they have that either this here could be floating and it can be connected to ground under certain conditions. It could be triggered to connect to ground, or it could be triggered for 12 volt DC to appear on that. Yeah. Depending on the system, in order to find out how the program buttons work on the specific model number, just look at the manual, or if you're not sure, call the manufacturer and ask. Right? Because they could vary from model to model, very rarely, but it can. So those can be used to trigger other equipment, power other equipment and whatnot. Now, and they're fully programmable based on condition. So it could be programmed to trigger if alarm goes on. It could be programmed to follow the alarm condition. Okay, it could be programmed to activate certain type of maybe door strikes. Door strike is a magnetic lock that locks the door, and you can release the door strike, press the button, apply the power, the magnet goes and it just releases the door so the door can be opened. Very common thing. And that could be interfaced with the swipe card, which is the access control system, or it could be manually operated. So you got some flexibility on how to connect some other peripherals to the equipment. Then you have the common terminal, and the common just appears in different spots, but it's the same terminal. It's just brought out to different locations, but it's the same term. Common is common. So there's one here, there's one here, it's the same thing. There's one here. It's just for your convenience because sometimes you are going to use the common terminal for in a lot of situations, like for example connecting a zone or connecting other equipment, and it's going to require a common terminal, so it's just scattered around the board for your wiring convenience. Right now, relay dry contact, so here is a common, and here is actually, you know what, in this case I would make sure that this common for this relay is the same as this common for the zones. Sometimes it is and sometimes there isn't. Okay, now here's a relay, here's a common pole, so it's like a double pole single throw switch. Well, it's like a three-way switch, right? And the relay is a dry contact relay, and dry contact means there is a contact that it's not connected to anything, so you can connect anything in it and not worry about affecting other circuitry. So here's a common pole, and it can be either normally closed or normally. So here's a normally closed terminal of this relay, and here's a normally open terminal of this relay. So if it's normally closed, so under normal conditions, under the idle conditions, these two are connected. And if the relay triggers, then the pole switches from this to that. So here's the common is connected instead of here, it's connected to normally open, and it closes. The normally closed and normally open just refers to the state of this device under idling conditions. And of course, the relay can be used to trigger other peripherals. And also the relay can work together with the program buttons, the program not buttons, program terminals as well. So you have some sort of flexibility. There's not one particular situation you would use it. If you need to interface this alarm system with something else, then maybe you can see, oh, how can we do this? We can program this and we can program that. Yeah, okay, it's not going to work. Okay, yeah, but it's going to work this way. It's sometimes you're going to have to troubleshoot and find solution. Problem solving. Okay, moving along here. You see here, here's the power that the not motherboard, but that the main board gets from just to be powered. Now here is another terminal, couple terminals, plus and minus, and it says AUX, auxiliary power. This is an output. This here, this terminal has 12 volt DC across this. So here would be 0 volts, here would be the 12 volts plus DC. This is the terminal that powers up anything that is connected to this board, like motion sensors, like glass break detectors, like keypads, and maybe some other devices that require to be powered, like for example, maybe an expansion board. Now, here's the thing about this terminal. It can provide certain amount of power. So when installing a security alarm, you should see all the motion sensors, all the other active devices, all the keypads, and see what the power consumption is. What is the current draw that this thing is going to require? And the devices in electricity, they don't ask for current. If it needs to get it, it's going to try to get that thing out of the battery or whatever the power supply is, right? So see what the power consumption or what the current draw is for a keypad, how many keypads are going to have. See what the current draw is going to be for the motion sensors that you're going to use in this particular system. Add them up and see if it's no more than this thing can provide. If it's more than this thing can provide, then you should consider installing a power supply expansion board. Right? So basically it's another board that has the AC inputs here, and it also has its own backup battery, and it's going to give you a little bit more power. It's just not going to have all these peripherals. So this is also this takes this AC thing here as a reminder. It charges the battery. It's a battery charger, or like a battery tender, and it gets the power from the battery when the power goes down on the system. All right, let's keep going here. Now we have a set of commons here, and these for sure, these three are the same terminal. They're just scattered for your convenience. All right, and there are zones. Zone 1, Zone 2, Zone 3, up to Zone 8. So this is the basic, sort of a small to medium size security main board, security panel, 8 zones. What is a zone? Zone is a contact point. The system can be programmed, and that's for the most part, that there is a dead short between the zone and the common. Then the zone is at ease, right? So if you just connect dead shorts, just run cable conductors and just connect them to commons here, ground everything, then the whole thing is at ease. But well, what's the purpose of it, right? Well, if you bring a wire out of the common, if you bring a wire, that it will become a pair. And the wire that is being used for that is Z type of wire, and for the most part is a quad, so it has 4 conductors, quad. And it's using the old color code. So it's remember the green, red, and black and yellow? But the old color code for the POTS lines is that pair 1 is green and red, and pair 2 is black and yellow. So if you connect the telephone, this is how you would use those pairs. Now, when you use the same cable for the alarm systems, you use that color code a little bit different. You see, you have black and red. Well, why not use that thing for power bus? Easy to remember if you have a motion sensor to be connected. So you get the cable run to the box, to this box here, and you connect the black and red right to the auxiliary power to power up the motion sensor. And on the other side, you would connect the black to the minus terminal, and you're going to connect the red to the plus terminal of the power input of the motion sensor. And you have the green and yellow. And the green and yellow you're going to use for the zone contact. So you would connect the green to common, and you would connect the yellow to the zone 1. For example, if you want to put that motion sensor on zone 1. So look what happens. Now the motion sensor is programmed to be normally closed. So that means if nothing happens, the contact is closed, providing a closed loop from the common terminal to the zone. So instead of just sticking a wire to it, you got the sensor device. If motion happens, if the motion sensor senses motion, it opens the contact. And that means this whole system is going to read open on zone 1. Now it depends whether this alarm system is armed or not armed. If it's armed, then, well, an alarm condition can be triggered. If it's not armed, then, well, maybe it's going to show you on the keypad that there's a motion in the living room. Okay? So those zones can be connected to different devices. Like, for example, you can connect zone 1 to the front entrance. Front entrance, door contact, and it's just going to be switch. So you're just going to connect the yellow and green, and you're going to forget that black and red, that those conductors are not going to be connected to anything, because a switch is a magnet operating switch. It's a reed switch, R-E-E-D. So it's like this here. It looks like a reed, just like the reed in a saxophone mouthpiece that vibrates when you pass air through it. So that's what it looks like. So that's why it's called reed switch. So when you get magnet close to it, switch closes. When you remove the magnet, switch opens. So just connect the yellow and green and connect it to zone 1. And you can program this zone as a delay zone. Well, because you have to enter your house, so you're triggering the alarm that is armed, but you don't want this alarm to go crazy because you're supposed to be entering your own home. So you can program this thing to have a 30-second delay before you punch the disarm code. Now, on zone 2, you can have in series all the door contacts, because for the purpose of simplicity, all those contacts like that, they're called door contacts, DCs. Right? You can put all those, all the windows that open in the living room could be armed with those contacts, and again, they can be put in series, wired in series, so they go from common through one connector to another connector to another connector, and you can put that in zone 2. And you can label that zone living room windows, and you can program this as an instant alarm. So if somebody opens the window when the system is armed, there is not going to be a 30-second delay. Boom, the whole thing is just going to trigger and cause all kinds of action, and so on. So those zones, even though it's just 8 zones, you can combine sensors on the zones to arm the whole house. You can have garage doors on one zone. You can have the overhead door, or maybe both of them in one zone. You can combine things to accommodate something that makes sense. It's a good idea to group all the outside parameter zones or sensors and not mix them with the inside doors. And the reason for that is there is something that's called a stay arm. And stay arm is a condition that you're arming the system, and some of the chosen sensors that are programmed for a stay arm condition are going to be armed, and some of the sensors are not going to be armed. Like, for example, if you want to go to sleep and you want to arm your house, but you don't want to cause false alarm if you just wake up in the middle of the night and you just want to go to the fridge and have a drink of water. Right? So under the condition of stay arm, all the outside parameter zones or sensors are active, are armed, and all the inside ones that you choose are not armed. Okay? So it's a good idea to, when you're grouping sensors in some sort of way, try not to mix the ones that can be included or can be not included in the stay arm condition. Okay? So that is the zones. We're going to look at a couple of slides that have a little bit more to do with the zoning there. All right, now here is the dialer. Okay. Ground is ground. Right. Now look at this. You can see ring and tip. Well, and then R1 and T1. So here's ring and tip, and here's ring 1 and tip 1. Does it mean you can connect 2 telephone lines into this system? No. Here's the ring and tip, and this is, well, if you want to still use, if somebody still has it, you can still use the POTS line, telephone line, to connect to the outside world if you want to communicate with something that's called a monitoring station. Just remember, the alarm systems do not call police. You would imagine that you could have some sort of pre-recorded message, and if something happens, then this thing is going to dial the police station, and when they pick up, the outgoing message is going to play, so and so there is probably, no, that doesn't work that way, right? Please do not receive any signals from the alarm systems. What is set up, well, what do we have set up around our area and pretty much everywhere else? It's something that's called a monitoring station or monitoring stations. A monitoring station is a business that somebody would set up to provide a service to public or to businesses to monitor the alarm systems. And that's all they do. They have staff 24/7. They're humans. They're sitting at the desk waiting for certain type of, triggered phone calls, right? Now, what happens if there's an alarm? The system can be programmed that it dials out and it connects with the electronic equipment of the monitoring station, and it communicates the signaling that so-and-so, here's the address, and well, there's a glass break sensor that went off, and there is a window that has been opened. Okay. And then when that happens, it happens very quickly, then the human that sits at the human receptionist that sits at the attendants, and there are a bunch of them there, and they're going to see a pop-up on their screen, and then they're going to see the instructions of what to do if something happens. Usually they call the premises, or they call the police right away, or whatever, depending on the sensor that has been triggered and the instructions that follow with that particular zone, for example, right? And some of the businesses are more highly secured than others. So the way things are connected to this thing here, if there's a POTS line, and if you want to use that, you would get the tip and ring right out of the demarcation points, right at the point of entry. So you grab the telephone line before it hits the rest of the house. And you connect that to the tip and ring here of the alarm system. Then you connect the line that you have just broken, and connect this to here. So the telephone line goes to the alarm system first, and then from there continues to the rest of the house. What do we accomplish by having this? If there is an alarm condition, the system is going to steal the telephone line. So if there is somebody that is talking on the phone in the house, or maybe the telephone wasn't hung up properly, or maybe there's some modem, that maybe there's something else using it's going to just cut them off, grab the telephone line, dial out monitoring station, communicate with the monitoring station, hang up, and release the line to the rest of the house. This is how the POTS works. And if you want to connect that, this is the proper way of connecting it. All right. So that's, in a nutshell, this would be how the main board works for the security alarm. Let's go and continue with this. So this, as I said, I also have this prepared for the in-class. So when I have that in-class class, then I have the Zoom versions of the slides. All right, so this is what the backup battery looks like, and see, it just connects right here. The fuse, the purpose of the fuse is that if it fuses that connector here, if there's an overload, then the fuse is going to go better the fuse than the rest of the board. Or sometimes, even if you are plugging this in and for some reason you reverse the connection, you plug the connector backwards, or you plug in these terminals backwards to the battery, the fuse is going to blow. All right, how is it that the sensors are being solved? Here's a door contact. Couple ways of wiring the door contact. You see, this here is the board, the main board, and this is in the field, so maybe this could be mounted in the door frame, or it could be mounted in the window frame, or something like that. Now look, there are two different versions that we have. One is we have the reed switch, and it's normally closed. Normally closed. If you just have that connector and put it on meter here, it's going to read open, and it's going to say it's normally closed. It's normally closed when the magnet is put close to it under normal conditions. So that's what they mean in this particular situation. So we just have yellow and green connecting to the zones, and that's it. You got a closed loop happening. And if something happens, if somebody opens the door, that means the magnet is being removed. So this will be on a door frame. Sorry, this would be on a door frame here because it's wired. And this would be on the door itself. So here's one way of doing it. Also, another way is connecting a end-of-line resistor. And if you do one way or the other, you have to let the system know which way you have chosen through the programming of the system. You can have two ways. You can have this just closed loop. You can have EOL, which is end-of-line resistor. And this is not something that you would, that's not how you would mount it. I'll show you why. Here's the auxiliary power, not connected. Here's the zone because it's a passive device. It's a passive device, and it would connect. If you connect the if you choose the end-of-line resistor route, so you have to program the system to recognize it as such and react properly. So it's not going to look for a closed loop. It's going to look for that resistance. And that resistance kind of varies from system to system. Well, this should be outside of that, past that. So you would run a wire past that, close that with the end-of-line resistor, and that's it. So over here you would have the line. We're going to continue somewhere else. The resistor come back and be connected here. And connected there. Well, why would you want to do that? It gives you extra. Basically, the resistor has to be in series with the whole loop. It gives you an extra level of protection. If somebody just wants to join these two when the resistor is outside of that, they're going to create a dead short. System is going to react. Right? If somebody breaks the line, you're going to create a break. System is going to react. What some systems offer is a combination of two, and also for that zone or system-wide programming, you can choose that option in the programming that, well, anytime you change something like this, you're going to have to let the system know that this is what you're doing. If you connect this here and that here to the same zone, you can trick the system to be treated as two zones. So you can make 16 zones out of 8-zone panel. Some systems have that capability, some don't. The best way, I always try to avoid that kind of solution. If I needed to get more zones, I would just get an expansion board. But something like that exists. All right, motion sensor. That's an active device. See here, this is the board, main board section. This is the terminal. These are the terminals on the motion sensors. Because here's showing 1, 2, 3, 4, but there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So normally you would connect that power, red and black, to the power terminals from the board. They would go to the power terminals on the motion sensor. And then here, the yellow and green, my mouse is disappearing on me. I just have to keep shaking my mouse here. So this would be the, well, just a dry contact. The purpose of that is to give you a dry contact. Open and close. That's all the system is looking for from the motion sensor. If it's just an old analog, you can have them digital, so it's a different story. And that's it. And all the rest of the circuitry has to do with how it is going to recognize a motion. Mostly it would be infrared or microwave sensor, or sometimes they use laser beams. You never know. Why am I showing you this? So that's right, it's a public knowledge. You can Google that. Plus, a properly installed alarm system. I could talk about this thing all night, all day. But the systems that I would install after I'm done, I wouldn't even be able to break into that house or facility myself after I have installed that. So that's a properly installed system. Right? Well, okay. Now we have 12 volts DC, and we have normally open, normally closed. It would usually use the common and normally closed system, and normally closed means that under idle conditions you have the opportunity to use the other contact of the relay, and sometimes this would not even have a terminal. And there are those two other ones. That's a tampere switch. You can wire that tampere in series with this loop. Here's a switch. There's a tampere switch. When you put the housing onto that, the tamper switch is closed. If somebody wants to tamper with the device, they will have to take the cover off. They're going to release the switch and the system is going to react. This is how typical zone security alarm contact point, I think it is. Here's the zone terminal, and you're gonna have the closed loop. So if you can combine, let's say, 3 living room windows on it. You can daisy chain them, connect them in series, and if all of them are closed, the system is at ease. If somebody opens one window, the whole thing is broken. The system is going to react. Cables that are being used is the Z cable, quad, 4 conductors. They come in 8 versions too. And these the old color code, red and black, green and yellow. That's how. Now, no twist. You see, I was always rigorous when it comes to connecting the data wires, but this is not a data wire. It's a security wire. A twist provides in a pair gives the pair inductive properties, so it acts almost like a coil. Coils do not like change. So if you have a twisted pair running to a door contact, if somebody opens and closes the door very fast, the signal might not have enough strength to travel through the coil-like twisted pair to let the system know that something has happened. So that's why you need to have an untwisted cable for security alarm contact lines. Okay? Sensors associated with the security alarms: motion sensors, door contacts, glass break sensors, smoke detectors, heat detectors, water level detectors, seismic, panic, and they could go in wire or wireless for the most part. Smoke detectors and the heat detectors, you could have the alarm to have certain fire alarm properties. Seismic sensors, they sense for vibrations. So safes in the bank would have those installed. If somebody wants to tamper with the safe, they will sense the vibrations. Glass break detectors, I told you how the motion sensors work. Well, for the most part, they sense the infrared signature of a human body, and then if it moves, then motion sensor reacts. Glass break sensor, it's looking for 3 things. It's looking for the high pitch shattered glass breaking. It's looking for that low frequency rumble that is for microsecond is present, or millisecond is present while the glass is just about to break. And it's looking for a sudden pressure change. All those 3 conditions present, it's going to react. The purpose is that to not produce false alarms. So if you have a cat at home and the cat just knocks out some kind of a glass object on the floor and that thing breaks, that is not supposed to trigger the alarm, because there will be a false alarm, and police do not like false alarms, and they will let you know about that, right? Mostly by sending you a bill. All right. Annunciators. Bell would be siren, strobe, and some alarms can be silent. Yes, they can be silent. They could just have a dialer. So the burglar goes in thinking, oh, there's no alarm, nothing makes noise. Well, there is alarm, right? So, and then how do we control that? We control through keypads. You can program that, but it's a very inefficient way. Most efficient way is laptop, and through the IP modules that we can use the remote access wireless remote controls. It's a user control. Alarm systems have remote controls now. You can go to your bed, shut the light down, and activate the alarm with your remote control from your bed. All right, interfacing. Alarm systems can be interfaced with other systems like access control, fire alarms, monitoring, and others. Fire alarm and security alarms, sometimes they work together. One can trigger the other. And access control, it's the door access control. That involves door strikes, involves swipe cards, proximity readers, fobs, and whatnot. So those some of the alarm systems have an expansion capability to make it into access control as well, and some of the alarm system can be interfaced with the access control. Okay, that's the last slide of today, and it is Friday today. It's not almost Friday, it is Friday today. So guys and gals, have a wonderful weekend. And I'm going to have to shut this thing, have to end this presentation, because in about 3 minutes I have another class that's also online. So let me just catch my breath. Have a wonderful weekend. I will see you when I see you. Thank you, guys.